students, how are you all? I hope that you all are good and we are successfully finished the series of basic mathematics used in physics and from today onwards I'm going to start class 11th physics from second chapter, that is units and measurements. Okay, so this is the first session of the second chapter of class 11, that is units and measurements. Okay, so in this session I'm going to discuss about physical quantities. So what are the physical quantities, what is the formula for physical quantities whenever they are changing from one system to another system of units, and the type of physical quantities. Okay, so and all these things that we are going to discuss in this session. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Physics. Okay, so what is the topic today? Units and measurements. So class number 1. Right. So our today's topic is physical quantities. This is a topic today, physical quantities. Right. So what is the meaning of physical quantities? So physical quantities means all the quantities, all the quantities in terms of which, in terms of which the laws of physics can be explained, the laws of physics can be explained and which can be derived, which can be derived directly or indirectly. Such type of quantities are called physical quantities. Okay, so what is the definition of physical quantities? All the quantities. Physical quantities means all the quantities in terms of which the laws of physics can be explained. So physical quantities can be used to explain the laws of physics. Also, which can be derived. So whatever the laws of physics can be explained by the physical quantities also can derived. We can derive the physics by the physical quantities directly or indirectly. Such type of quantities are called physical quantities. Is it clear? Right. So the next concept is types of physical quantities. Types of physical quantities. So physical quantities can be classified into three types. How many types? Three types. Okay. So the first one is fundamental physical quantities. This is the first one, fundamental physical quantities, and the second one is derived physical quantities, derived physical quantities, and the third one is supplementary supplementary physical quantities. So the first one is what? Fundamental physical quantities, and the second one is what? Derived physical quantities, and the third one is what? Supplementary physical quantities. So first we are going to discuss about fundamental physical quantities. What is the meaning of fundamental physical quantities? That means the physical quantities which does not depends upon any other physical quantities. What is a fundamental physical quantities? The physical quantities which does not depends upon any other physical quantities are called fundamental physical quantities. So the physical quantities which does not depends upon any other physical quantities, such type of physical quantities are called what? Fundamental physical quantities. Okay, right. Fundamental physical quantities are classified into seven types. Classified into seven types. So the fundamental physical quantities are classified into seven types. Have a look. So fundamental physical quantity, okay, and it's a SI unit and a symbol. Okay, fundamental physical quantity and the SI unit and the symbol of that physical quantity. So the first one is mass. First one is what? Mass. And its SI unit is kilogram. SI unit is what? Kilogram. And its symbol is kg. And its symbol is kg. And the second, length. Second one is what? Length. SI unit is meter. SI unit is what? Meter. And its symbol is small m. Symbol is small. And the third one is time. Third one is what? Time. And its SI unit, second. Okay. So symbol is S. Symbol is what? S. And the fourth one is temperature. Temperature. So SI unit of temperature is Kelvin. SI unit is what? Kelvin. And the symbol is K. Okay. So the fifth one, amount of substance. Amount of substance. So the SI unit is mole and its symbol is MOL and its symbol is mole. And the sixth one, luminous intensity. Luminous intensity. And SI units are candela. SI units are what? Candela. So symbol is CD. Symbol is what? CD. And the seventh one, electric current. Electric current. And the SI unit is ampere. SI unit is what? Ampere. And its SI units are capital A. So these are the seven fundamental physical quantities. Okay. So by using these fundamental physical quantities, we can write all the formulas that exist in our physics. Is it clear? Any doubts? Okay. Right. So these are like alphabets in our English. That means, so if you want to write one spelling ARE, what you need? You need ARE. So from these alphabets, we can write the formula of ARE. So what is A? What is R? What is E? ARE are the fundamental physical quantities. For example, so likewise, in a physics, if you want to write any formula, we must require these seven fundamental physical quantities. Is it clear? Right. 3, 2, 1. Pause the video and write the notes or take the screenshot. Right. So the second type of physical quantity is what? Derived physical quantities. Derived physical quantities. Okay. So the physical quantities which are derived from fundamental physical quantities are called derived physical quantities. The physical quantities which are derived from fundamental physical quantities, that means this derived physical quantities are derived from fundamental physical quantities. Let us see an example. Area. What is an area? If you want to find the area of this board, what you will do? You take the length of the board and the width of the board. So that means area is equals to what? Area of the board is equals to what? Length into width. Okay, length into width. So SI unit for length is what? Meter, and width is what? Meter. Meter is nothing but length, and width is also nothing but length. See, 10 meters, 2 meters, 4 meters. Width is also in a meters. That means length is nothing but length, and width is nothing but length. Okay, so both we measure in meters only, then we get meter square. So now area is what? Derived physical quantity. It depends upon what? Meter, meter. Meter is nothing but what? It's SI unit for length. What is length? Length is a fundamental physical quantity. Now area is what? Derived physical quantity. A, B, C are the alphabets. That means they are fundamental physical quantity. So area, A-R-E-A, it is a word which is derived from alphabets. Then it is called a derived physical quantity. And the mass, length, time, temperature, amount of substance, luminous intensity, and electric current, all these are called what? Fundamental physical quantities. From that fundamental physical quantities, we are deriving derived physical quantities. So the second example, volume. What is volume? Volume is nothing but length into width into height. So SI unit for length, m, meters. So the SI unit for width, meters, and the SI unit for meter, height. So SI unit for height, meter. So meter into meter into meter, meter cube. This is what? SI unit. Okay, so this is also SI unit for volume. What is that? Meter cube. See, meter, SI unit of length, meter, SI unit of length, meter, SI unit of length, m into m into m, it gives m cube. That is volume, SI unit of volume. Now the volume is which fundamental, which quantity? Derived physical quantity. It is derived from fundamental physical quantity. So the third one, velocity. What is velocity? Displacement by time. Displacement by time. Have a look. Displacement. Displacement is nothing but what? And just to make a 2 meters of displacement. Okay, so 2 meters. 2 meters is nothing but what? Length. Okay, now displacement is nothing but what? Length. Time is nothing but what? Time. That means it is a fundamental physical quantity. So displacement is nothing but length. Okay, so length is which physical quantity? Fundamental physical quantity. So the ratio of two different fundamental physical quantities gives velocity. Now the velocity is derived from fundamental physical quantity. So velocity is called what? Derived physical quantity. Okay, dpq, derived physical quantity. So displacement is nothing but what? Length. SI unit for length is meters divided by time. SI unit for time is second, meter per second. So SI unit for velocity is what? Meter per second. Are you getting? What is the difference between fundamental physical quantities and derived physical quantities? So fundamental physical quantities are like alphabets. Okay, derived physical quantities are like words which are derived from alphabets. Is it clear? Right. So the third one. So the third one I'm taking a fourth one. Right. So the fourth one is acceleration. Fourth one is what? Acceleration. Acceleration is nothing but what? Velocity divided by time. Velocity divided by time. The rate of change of velocity is called acceleration. Okay. So what is velocity? Again, velocity is nothing but displacement by time into another time term is there in a denominator, displacement by time. So what is displacement? Displacement is nothing but length. SI units for length are meter divided by time into time square. That means second square. So this is fundamental physical quantity and this is also fundamental physical quantity. So the ratio of two different fundamental physical quantities are given. Another derived physical quantity, that is what? Acceleration. Is it clear? So this is what? SI unit of acceleration. SI unit of acceleration is what? Meter per second square. Are you getting? So likewise, we can write down any formula by using what? The fundamental physical quantities. Okay. So next one, force. Force is equals to what? Mass into acceleration. Mass into acceleration. So what is mass? Mass is nothing but kg into acceleration, meter per second square. Meter per second square. Meter, fundamental. Second, fundamental. Kg, fundamental. By using these fundamental physical quantities, we find a new derived physical quantity, that is what? Force. So what is this? SI unit for force. Is it clear? Any doubt? Let us see one more example. Momentum. Momentum. So momentum is equals to what? Mass into velocity. Momentum is equals to what? Mass into velocity. Right. So what is mass? Mass is fundamental physical quantity. What is the SI unit? Kg. Into velocity. Displacement by time. Kg meter per second. See, kg meter per second gives momentum. Kg meter per second square gives force. So by using the fundamental physical quantities, we can derive the derived physical quantities. Is it clear? So this is what SI unit for momentum. Are you getting the difference between fundamental and derived physical quantities? Right. So pause the video, write the notes. 3, 2, 1, go. So right. So the third type of physical quantity is what? Supplementary physical quantity. Supplementary physical quantity. So supplementary physical quantities are two types. How many types? Two types. The first one is a plane angle. First one is what? Plane angle. So that means I'm taking a circular arc. The circular arc is like this. Okay, so this is a radius of the circle, and this is a angle made by the radius. Okay, that is what? An angle theta. So the length of the circular arc, let us say ds. So ds is the length of the circular arc. So now the plane angle theta, plane angle theta is equals to, we can write arc upon radius. Arc upon radius. What is arc? Arc is nothing but this one. So that is what? ds divided by radius. What is radius? R. And angle theta is equals to what? ds by r. Arc upon radius. And this theta is called what? Plane angle. Theta is called what? Plane angle. So SI unit. So SI units are radians. SI units are what? Radians. So symbol. So symbol is a RAD. Symbol is what? RAD. So right. The second type of supplementary physical quantity is a solid angle. What is that? Solid angle. And a solid angle can be denoted by d omega. Solid angle can be denoted by d omega. So okay, so this is the surface area of a circle. So that is a dA. Okay, and from the center we are taking an angle. So this angle is called d omega, that is solid angle. And the solid angle d omega is equals to, we can write dA by r square. dA by r square. So this is the formula for solid angle. Okay, dA by r square. So SI units. So the SI units are steradians. SI units are what? Steradians. So let us see one note. So, so 2 pi radians, we can write 2 pi radians is equals to 360 degrees. 2 pi radians is equals to how much? 360 degrees. And second one, pi radians. Pi radians is equals to 180 degrees. Pi radians is equals to what? 180 degrees. Now this value can be written as pi into 1 radian. Pi into 1 radian is equals to 180 degrees. So pi ones are pi radian. Pi radians. We get the same thing. Okay. So then 1 radian is equals to, if multiplier went to this side, it comes to denominator 180 degrees by pi. So therefore, if we solve this, we can get 1 radian is nearly is equals to 57.3 degrees. 1 radian is equals to how much? 57.3 degrees. What is the value of pi? 22 by 7, which is nearly equals to 3.14. Okay, if you substitute this value here and if you make a division, we will get a 1 radian value which is nearly equals to 57.3 degrees. Is it clear? Are you clear? Any doubt? Right. So pause the video and write the notes. 3, 2, 1, go. Right. So the next concept is a conversion factor. What is that? Conversion factor. So what is a conversion factor? That means to convert physical quantities from one set of units to another set of units, we require a multiplier. We require a multiplier factor that is called a conversion factor. That is called what? Conversion factor. So what is a conversion factor do? It can convert the physical quantities from one set of units to another set of units. Okay. So now we can write, so physical quantity is equals to n into u. Physical quantity is equals to what? N into u, where n tends to numeric value, n tends to what? Numerical value, and u tends to unit. U tends to unit. Okay. So when we are changing the physical quantity from one set of unit to another set of unit, its magnitude, the magnitude of physical quantity is remains constant. The magnitude of physical quantity remains constant. When it is constant, when we are converting physical quantities from one set of units to another set of units. Therefore, we can write n into u is equals to what? N into u is equals to what? Constant. N into u is equals to what? Constant. So because the magnitude of the physical quantity remains constant, see, pq is equals to constant, n into u is equals to constant. Right. That means the numerical value is inversely proportional to unit. Numerical value inversely proportional to unit. Okay. So therefore, we can write this formula as n1 u1 is equals to n2 u2, and this formula can be used to convert physical quantities from one set of units to another set of units. So this formula can be used to what? To convert physical quantities from one set of units to another set of units. Is it clear? Right. So this is the end of the today's lecture or today's session. In this session, we have discussed about what? Physical quantities and the type of physical quantities. So physical quantities can be classified into three types: fundamental, derived, and supplementary. So there are 7 fundamental physical quantities are there. So by using those 7 fundamental physical quantities, we can write all the formulas in a physics. Is it clear? So this is the small concept. So what is the conversion factor? Okay. I hope that you understand this lecture, and we will meet in our next lecture, that is units and measurements, class number 2. In that session, we are going to discuss about our important concept, that is a dimensional analysis. Is it clear? Right. So this is Rakesh signing off. Jai Hind.